Hello, this is Chitran Shaksana, and in this video today we are going to learn about motion. So the objectives of this video will be, the very first is introduction, then motion along a straight line, uniform and non-uniform motion, then distance time graph of motion. Let's move ahead and start learning. Introduction. So the process of an object moving or changing place or even just changing position is motion of an object. It is a manner in which an object moves. So we can define it as an object is said to be in motion if it changes its position with respect to its reference point. Now, what is reference point? Let's have a look on this example. Here, this is simple pendulum moving to and fro about its reference point. See, this is a simple pendulum. This is its reference point. It is moving to and fro about its reference point. Now there are some types of motion which are mentioned here. The very first is rectilinear motion. It is a motion in a straight line when an object is moving in a straight line. The second is curvilinear motion, when an object moves along a curved path. An oscillatory motion, the to and fro motion of an object is said to be an oscillatory motion. For example, motion of an pendulum. Rotatory motion, when an object moves around a fixed point, like it can also be said circulatory motion. When let's say for example it is a thread and a stone is tied here and we rotate it like this in a circular way, this is called rotatory motion. Then vibratory motion, the motion of a sitar string exhibits vibratory motion. Or anything, if you take a rubber band, a small rubber band, and stretch it and then put a finger, it will start vibrating, and that motion is known as vibratory motion. Now, motion along a straight line, as we have just discussed that a motion is along a straight line is known as rectilinear motion. So here it is explained again. Motion along a straight line is the simplest form of motion. It is a motion along a horizontal or vertical or inclined line. It is also known as a rectilinear motion. An example, as you can see, this car starts moving from origin. This is origin 0 along a straight path to a point at 30 meter, showing a rectilinear motion because this car is moving on a straight path. We can say it is on a straight line, so that's why it is rectilinear motion. Now, uniform motion. A body has a uniform motion if it travels equal distance in equal intervals of time, no matter how small these intervals may be. For example, if I say an object is moving 5 meters in every second, so the motion or speed will be 5 meters per second, and if I ask that how much will it travel in 3 seconds, so it will be 15 meters because it is moving 5 meters in every second. So 3 seconds it will in 3 seconds it will travel or cover 15 meters. Now for this graph, as you can see, a car is, let's say this is a graph for a movement of a car which is running at a constant speed of 10 meters per second. It will cover equal distance of 10 meters every second. So its motion will again be a uniform motion. You can see this is 1 second, 10 meters, again another second, another 10 meters, same it goes on. The distance time graph for this uniform motion is a straight line, always remember. Now, can you think about the distance covered at 5th second? Yes, you are correct. It is again 10 meters because it is 5th second. If we ask that how much distance will it cover in 5 seconds, so it will be 50 meters. That's good. Let's move ahead. Non-uniform motion. As by the name, we can very well understood that the motion which is not uniform, that is non-uniform motion. But in a particular manner, how we will say it? We'll say it like, a body has a non-uniform motion if it travels unequal distances in equal interval of time. First, let's say an object moves in first second 2 meters, in the second second it moves 3 meters. In third second it just moves 1 meter. So all in all, in 3 seconds it moved just 6 meters. This is an example of non-uniform motion. And always remember, the distance time graph for non-uniform motion is a curved line, as you can see it here. One example we can discuss again here. If we drop a ball from the roof of a tall building, we will find that it covers unequal distances in equal intervals of time. It covers 4.9 meter in first second, 14.7 meter in second, 24.5 meter in third second, and so on. So, a freely falling body always exhibit a non-uniform motion. Now, how do we represent motion by a graph? So here we have distance time graph for a uniform motion. When an object is moving with uniform velocity, the slope of graph is always a straight line. See, this is a straight line for this graph. In other words, slope of a straight line of a distance time graph shows that object is moving with uniform velocity. The next graph is velocity time of uniform motion. The slope of velocity time graph of an object moving in rectilinear motion with uniform velocity is a straight line and parallel to x-axis when velocity is taken along y-axis and time is taken along x-axis. You can see here velocity is on the y-axis, time is taken on x-axis. So the curve or the graph for velocity time graph will be a straight line and it will always parallel to x-axis. The next is distance time graph for non-uniform motion. When graph of a distance time graph is plotted for an object moving with accelerated motion, that is, with increasing or decreasing non-uniform speed, the slope of graph will not be a straight line. The rising trend of slope shows the increasing trend of velocity and vice versa, as you can see here and in this picture. Next is graphical representation of motion with velocity time or graph of non-uniform motion. Velocity time graph of an object moving with increasing and decreasing acceleration. You can see here in this picture. Now here are some practice questions for you. You can again pause the video for trying these questions, and after that you can check your answers. Here are your answers for all the questions. If your answers are correct, then very well done. And that is all for this video. For more videos, you could log on to justtutors.com. Thank you.